All right, everyone, now that we have already had a discussion about predictions, you should have participated with that either on eClass or in our in-person discussion. We want to get started talking about stoichiometry, okay? Now, stoichiometry is the title of this unit, and it's basically the study of relationships, and it uses a balanced chemical equation to do so. So it uses balanced chemical equations. So yes, balancing chemical equations is coming back into our lives, and it's used to study the relationships between the amount of reactants that are used and the amounts of product that are created. And so the coefficients in these balanced chemical equations are useful because that is what we use to identify our mole ratio between the compounds. Now, a mole ratio is important. It allows us to compare the moles. So in a balanced chemical equation, the coefficient in front is the number of moles. So this would read 2 moles of hydrogen gas plus 1 mole of oxygen gas will produce 2 moles of water vapor. And we can see that the mole ratio between hydrogen and water is 2 to 2 because they both have a coefficient of 2. But the mole ratio between oxygen and water is 1 to 2. Now notice it is not 2 to 1. That would be incorrect. Oxygen is listed first in what we're describing the mole ratio, so the coefficient for oxygen must come first here, which is 1. And so we can use mole ratios in T-charts the same way that we do molar mass or Avogadro's number. Okay, so if we look at this problem here, okay, we can see an example. So it says how many moles of water are produced by 27 moles of oxygen gas. So one thing to note is we know that we're given 27 moles of oxygen gas, so 27 moles of oxygen. And what we're trying to find is the moles of water, okay? Because it says how many moles of water. But when you look at our units, normally we analyze these to find our conversions or equalities that we need, whether or not we need molar mass or Avogadro's number. But here our units are staying moles, but our chemicals are different. So when you have different chemicals in what you're given and what you're trying to find, that means you will need the mole ratio through the balanced chemical equation to be able to solve it. So if I want the mole ratio of oxygen to water, we know that it's 2 to 1 or 1 to 2, and we can write it 2 different ways. We can write it with 1 mole of oxygen at the top and 2 moles of oxygen at the bottom, or excuse me, of water at the bottom, or we can flip it. Now keep in mind, you have to have your chemical formula in your chart because we are not using the same ones. So I know that if I start with 27 moles of oxygen, then moles of oxygen must be at the bottom, which is why we are using the flipped version and not the first one. So 27 times 2 divided by 1 gives us 54 moles of water. And so looking at this example and based on our explanation, you should be able to answer these 3 questions. So go ahead and pause the video and then press play when you're ready to go over the answers. Okay. I misspoke earlier. We're not actually going over the answers. You should have them. But what I will do is go over an example here. So if we look at this example, so what is the mole ratio between CH4 and CO2? We can see that there's a coefficient of a 1 in front of CH2 or CH4 and also a coefficient of a 1 in front of CO2. So we should have a mole ratio of 1 to 1. I'm going to skip number 2. What I want to really do an example of is number 4. And this is going to involve both molar mass and our mole ratio. So it says how many moles of CH4 or methane are needed to react with excess oxygen to create 100 grams of water. Now there are 3 different chemicals mentioned here, but only 2 of them are important. It's really, really important that you label what you're given and what you're trying to find. So when we do this, we see that we're given 100.0 grams of H2O, and we're trying to find the moles of CH4. Now it mentions excess oxygen, but that doesn't matter. All it says is that you have more than enough oxygen for this reaction to happen, so you don't even need to consider it. Now when we analyze our units, whenever we see grams here, this tells us that step number 1 is going to be the molar mass. Now, unlike previous problems that we've always had the same chemical, but because the grams is next to water, that means I need the molar mass of water. Now, the fact that I have moles over here means I don't really need to worry about anything. But my chemicals are different. And because they're different, that means step number 2 is going to be using the mole ratio. Okay, so let's go ahead and get our things that we need. So the molar mass of water, okay, I'm not going to work out the calculation because at this point you should be able to do molar mass. But the molar mass of water is 18.02 grams of water over 1 mole of water. Or, you know, we could flip it in our chart. And the mole ratio for water and methane, if we look at our chemical equation up here, water has a coefficient of a 2. So I'm going to put 2 moles of water at the top. And then methane has a coefficient of a 1. So that means we'll put 1 mole of methane or CH4 at the bottom. And of course it can be flipped. Now that we've identified what conversions we need, we'll put it into a T-chart. We take what's given to us, and it's the same procedure as we've always done, okay? If we have grams of water here, that means that grams of water must be at the bottom of my chart. The only one of our fractions that have grams of water in it is our molar mass. And since grams of water is written at the top, we are going to need to flip this so that our 18.02 grams can be at the bottom and my 1 mole of water can be at the top. Now this is good because we've gotten rid of grams and we're in moles, but we still have water, and what we're trying to find is moles of methane or CH4. So we need to do a second step. If I have moles of water here, I need to have moles of water at the bottom of my next fraction. And I know that my next fraction is mole ratio because we've already used molar mass. So mole ratio is next. And actually we're going to need to flip this one because it's got moles of water at the top. So 2 moles of water at the bottom, 1 mole of CH4 at the top. And since moles of CH4 matches what we're trying to find, that means we are ready to put this in our calculator. So it'd be 100 times 1 times 1 divided by 18.02 divided by 2. And when you put that in your calculator, you should get that there are 2.775. Remember, our given has 4 significant figures, so we're going to keep 4 significant figures in our answer, moles of CH4. And so we can combine it with a molar mass conversion the same way we are doing in Unit 1. So go ahead and work on the other practice problems and notice that the answers are in parentheses for you to be able to check your work. Good luck.